A very good morning to all the students. I hope every one of you is fine and in your best health. So we were doing the chapter carbon and its compound, and today we'll be reading about hydrocarbons. Hydrocarbons are simple those compounds which are made up of hydrogen and carbon only. That means a hydrocarbon is nothing but just a mixture of hydrogen and carbon. So when hydrogen and carbon combines, it forms hydrocarbon. Okay, so the definition of hydrocarbon is just the compounds which are formed by combination of hydrogen and carbon, and those compounds are called as covalent compounds because in the covalent compounds there is just sharing of electron, no transfer of electron. Now we have read about this in our previous lecture about covalent compounds, what are they and how are they formed, and the ionic compound also we have read in the previous chapter number 3. In the ionic compounds there is transfer of electrons, but in the covalent compounds there is sharing of electrons. So hydrocarbons are of basically two types, but before that I want to explain you that hydrocarbons are of into two different categories actually. That is, if we discuss hydrocarbon, okay, so it is of two major types. One is aliphatic and the other one is cyclic. Okay, so cyclic means it forms cycle or closed chain, because we know that carbon forms catenation, that means it forms a long chain, and this one is open chain. So when there is an open chain we call it aliphatic hydrocarbons, and when it's a closed chain we call it cyclic. So now aliphatic is again of two types, that is saturated and unsaturated hydrocarbons, and this is also hydrocarbons. Okay, so hydrocarbons are of two types, that is aliphatic and cyclic, and in this aliphatic there are again two types, that is saturated and unsaturated. Now saturated and unsaturated, again we can define that when there is only single bond, that we will be studying today. When there is only single bond, that is called as saturated, and when there is double or triple bond, then we call it an unsaturated. Now again this unsaturated is of two types, that is alkenes and alkynes. So we will be studying about saturated and unsaturated in details, and cyclic also will study, but it does not have any other types, it's just only of one type. Now this has a formula, that is the general formula in this alkenes is because it is alkene, that means it has a double bond. It is alkyne, it has a triple bond, and this saturated hydrocarbon just has one single bond, and we call it as alkane and single bond. This bond is of carbon and hydrogen bond, because we are learning about hydrocarbons. So when hydrogen combines with carbon it forms hydrocarbon, so there will be a single bond, how we'll be studying in today's lecture. So again one more thing is that they have a general formula which is called as CnH2n plus 2. This also I will be explaining you. This has general formula CnH2n, and this has a general formula of CnH2n minus 2. This you have to learn, but the IUPAC naming is not in your syllabus for this year. because if had been it there, it would be a great help. But again, in class 11th you will be learning this, so if you learn the general formula, it will be easy for you to identify whether it is a alkane, alkene or alkyne. Now saturated hydrocarbons, and this has lots of difference. That means in this all the 4 valencies of the carbon atoms are satisfied. That means all the atoms, all the electrons will get the other electron to share with, and the atom will become stable very easily. But in this, the valencies of at least 2 carbon atoms are not fully satisfied, and therefore they form double or triple bonds. Okay, and in this, the hydrocarbons, if we'll burn them, they will be burned with a blue flame, and they contain the more percentage of hydrogen and less percentage of carbon, and they have more concentration of carbon and less of the hydrogen, and they are less reactive because they don't have any availability of electrons in the single covalent bond, but they are more reactive because these have the presence of electron in the double or triple bond, and they go substitution reaction and they go addition reaction. Now substitution reaction and addition reaction is also has been cut from the syllabus, so we will not go in detail, but we'll just study the superficial. Okay, so with this I would like to explain you what is the organic chemistry about. Now organic chemistry is the branch of the chemistry which deals with the study of hydrocarbon and their derivatives. So derivatives means the types of the hydrocarbons, that means the organic compounds which contain few elements such as carbon, hydrogen, oxygen, nitrogen and sulfur. So they are the organic compounds, and they form a new compounds like methane or like acetic acid and alcohols and a lot of things like that. Okay, so coming back to a topic which we were studying, that is types of hydrocarbon. As I've told you, hydrocarbons are basically of 2 categories, like they are divided into 2 types, aliphatic and cyclic, and then again aliphatic is subdivided into 2 types, which is saturated and unsaturated hydrocarbons, and then again this is divided into more subtypes, which is alkenes and alkynes, and for this we call it alkene. Okay, now back to our topic. We were studying saturated hydrocarbons because they are the major 2 types, because cyclic will be learning in the this chapter itself. So saturated are those which have single bond, and they are called as alkanes, and unsaturated hydrocarbons which have either double bond or triple bond. For double bond we call them alkenes, and for triple bond we call them alkynes. Okay, KYNES, and here it's kenes. You have to remember this: alkane, ANE, cane, single bond; alkene, double bond; and alkyne, triple bond. Okay, so before we start this, I will again try to tell you what single, double and triple bond are, since we have done it in our previous lecture, but again I will be telling you now single bond. Okay, so single bonds are the bond which are formed by sharing, because this is a covalent bonding, so obviously it will be sharing of one pair of electron between the 2 atoms. That means when 2 different atoms will share the electrons, so they will have a single pair. That means only 2 electrons between the atom. Each atom contribute 1 electron for sharing. That means they will be sharing of only 2 electrons. That means, example here is chlorine. Chlorine has 7 electrons in its valence shell. So chlorine needs to have 8 electrons to fulfill their octet structure and to become stable. So here this chlorine also, the other atom of fluorine has 1 electron here, 7 electrons, so it wants 1 electron, so both of them want 1 electron, so they will share 1 electron. So they will be a sharing, that means like this, they will share, it is called as electron dot structure also. So they will be sharing this electron, 1 from here and 1 from here. So basically it will be 2 electrons sharing between the 2 atoms. So it will form a single bond. One more example I would like to tell you is that, for example, hydrogen here. Hydrogen has only valency 1. So one atom of hydrogen combines with the other atom of hydrogen. Okay, so how it will form? It will form like H and H here, so it will be a bond. So both of them are having 2 electrons. This is also having 2 electrons, and this is also having 2 electrons. That means it has completed its duplet. And we can also make like this, hydrogen and hydrogen. That means it's a single bond, like it is sharing one electron. So this is an example of single bond. Okay, one more example will take its that HCl. Okay, HCl. Now this is chlorine combined with hydrogen. It is not a hydrocarbon because there is no carbon in this. If it had been here carbon, we would have called it hydrocarbon. So example here is HCl. So 1H, 1 electron, and chlorine has 7 electrons. So 1, 2, 3, 4, 5, 6 and 7. So again it will share the electron. How? Like this, hydrogen 1 and chlorine 1. We can also mark it with X. It would be easy for us to understand. So let it will be X here. So it will form a bond like this and a bond like this. Sharing, so hydrogen is sharing 1 electron from the chlorine, and chlorine is also sharing 1 electron from the hydrogen, and hence they both are having their octets complete. So it has formed a covalent bond. That is, we can also write like this, H single bond Cl. Okay, it will be Cl here. So it's also a single bond. So whenever there is a sharing of only 2 electrons between the atom, okay, or one pair means it's only one pair. 2 electrons means one pair. So that is called as a single bond. Okay, now next is double bond. When a double bond is formed when there is sharing of 2 pair of electrons, that means there will be 2 pair of electrons and between the atoms. So by sharing 4 electrons between 2 atoms, each atom contribute by 2 electron sharing. So there will be 4 electrons sharing, and then it will be sharing 4 electrons in 2 atoms. Okay, so from one atom there will be 2 electrons, and from the other atom also there will be 2 electrons. So 2 from each one of the atoms. So all total there are 4 electrons. Example. So example is very simple, like we'll take example of the oxygen here. So oxygen has 6 electrons in its outermost shell, and it needs to have 8 electrons. So here this oxygen atom, because oxygen, hydrogen, nitrogen are all diatomic gases. We have learned in class 9th. I hope you all remember that. So oxygen is a diatomic gas, so it forms a bond between itself. So by covalent bonding, like from the sharing, it will share 2 electrons from the other oxygen, and so as this oxygen will share 2 electrons from this oxygen, so 2 of its and 2 of its, so it will be 8 here and 8 here. So this is a double bond because the overall sharing is of 4 electrons, but 2 from one and 2 from one. Okay, so this is what the definition was. The definition was that in the double bond is sharing of 2 pair of electrons between the 2 atoms. So by sharing 4 electrons between the 2 atoms, each atom contribute 2 electrons by sharing. So here is the double bond. Okay, we have more examples of double bond. Example, we'll take CO2. Okay, now CO2 is also not a hydrocarbon, it's just a covalent compound. So in this, as oxygen is 2, so we'll write 2 oxygen, and C is only 1, so C here. So carbon has 4 electrons in its outermost shell. So it will be like this, 2 carbon, 2 electrons and 2 electrons here. And oxygen has 6 electrons. So it will be like this, 1, 2, 3, 1, 2, 3, 4 and 5, 6. Okay, and 1, 2, 3, 4 and 5, 6. Okay, so it is having 6 electrons. Sorry, what I've made? Okay, 1. Okay, it's right. 6 here, so 1, 1 and 4 here. Okay, so how it will happen? Like it will be plus. So this oxygen will be sharing because it wants 2 electrons from this carbon. Okay, if you'll count, it will be 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 electrons, and this again will be sharing 2 electrons from here, so again 8, and this carbon will be sharing like this. Okay, I hope you understand. So it will be forming double bond here and double bond here. Okay, so that means it is having double bond. So this is an example of double bond, although it has making double bond from both the sides, but it is a double bond. Okay, now example of triple bond. Triple bond is the formed by the sharing of 3 pair of electrons. Now here it's 3 pairs, that means 6 overall electrons will be shared. So the bond formed by sharing 6 electrons, that means 3 from each atom. One atom will give 3 electrons and the other atom will also give 3 electrons. So each will contribute 3 electrons by sharing, and overall sharing will be of 6 electrons. Example, nitrogen here. So nitrogen has the overall the electrons in its outermost shell is 5, because valency of nitrogen is 7. So 1, 2, 3, 4, 5 here and 5 here. So it will be sharing 3 electrons from one atom and the 3 from the other atom. So the overall sharing is of 6 electrons. So here I've shown like 6, and it will form a triple bond because it is a sharing of 6 electrons. So it will be a triple bond. One more example of triple bond would be, it is very simple, like we take ethyne. Ethyne, it's a hydrocarbon which is a form of saturated hydrocarbon, and it is from alkyne. So alkyne, we name it because we don't have naming in our syllabus this year. So we name it like meth, eth. So eth is the second order of the this homologous series. But homologous series will be learning. So ethyne, so it just the formula is C2H2. So it will be like C is 2, so C will be 2 carbon and then 2 hydrogen only. Okay, so since the carbon has the 3 electrons here and 1 here and 3 here, because overall 4, and it has only 1, so it will form a, no, I have done the wrong, 3 here and okay, this is 3 and 1 here. So 3, it will form a bond like this, and this will combine with this. So it will count, it will overall, and it will be, we'll count here, if it will be 8 electrons, 1, 2, 3, 4, 5, 6 and 7, 8, and again for this C also it is having 8 electrons. It's not that clear. We'll just count this. Okay, it's a little messy. So 1, 2 and 3, and 1, 2 and 3. So triple bond, and this is having only 1 electron here because carbon has only 4 electrons and hydrogen has 1 electron, and here also it's only 1 electron, and here it's 1 electron. So one will be shared from, hydrogen will share this electron, so hydrogen has 2 electrons, and this hydrogen will share with this C at 2, and then this C will share 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8, and this C will again share 1, 2, 3, 4, 5, 6, 7, 8. So this is a triple bond. Okay, so this is having 8, and this is also having as well 8, and this is really messy, and this is also having 2 electrons, and this is also, I hope it's clear. Okay, if not, I'll explain you again. So after this, now since we have done this single bond, double bond and triple bond, now we move to the main topic of ours which we have to study, that is saturated hydrocarbons. In the beginning of the lecture, I told you that hydrocarbons are basically of 2 types, that is aliphatic and cyclic, and in the aliphatic there are 2 types, that is saturated and unsaturated. So first we'll be doing the saturated hydrocarbons. Okay, now this is a hydrocarbon in which the carbon atoms are connected by only single bond. So just now we have read about bonds. So this is a type of hydrocarbon in which the carbon atoms connects with only single bond with the hydrogen, because carbon combines with hydrogen, we call it as hydrocarbon. So the first example is methane. Now it is a naming which the first is called as when it has only 1 carbon atom. so we call it as meth. And when it has 2 carbon atoms, we call it as eth. And when 3, prop. And when 4, bute. 5, 6, hex, and so on, like this. Okay, so this hex must 6 carbon atoms, so number of carbon atom is 1, 2, 3. Now it has a general molecular formula, not molecular formula, of CnH2n plus 2. Now what is this N and what is this 2 and all? So here N means N equals to the number of carbon atoms actually. Okay, so N here defines the number of carbon atoms. That means how many carbon atoms are there in any kind of a hydrocarbon. Okay, so if N equals to 1, that means according to the formula, when C is 1, so H will be 2N, that means 2 1 plus 2, that makes it, when N will be 1, that means when carbon will be 1, that carbon is 1, so N is 1, so H is 2N, so 2 into 1 and plus 2, so it will be C only 1, and H is 2 into 1 plus 2, that means 4, CH4. And when N equals to 2, what will, then C is 2, then H will be 2 into N, that is 2 plus 2, that means C 2 and H, it is 2 into 2, 4 plus 2, it is 6. Okay, and then when N will be 3, again C will be 3, H will be 2 into 3 plus 2, that means C3, 6 plus 2, 8, and so on we can find out. So here, like when N is 1, so what will be the molecular formula? It will be CH4. Okay, CH4. When N is 2, it will be C2H6. Okay, like this. Now when N is 3, it will be C3 and H. What is H? 8. Okay, so this is how we're going to write. Then again 4, it will be C4H10. Then when it's 5, it's C5H12. It's 6, it's C6H. H will be capital 14. Okay, like this we have to write. Now we will be learning about structure. Now when it's meth, so since it's CH4, so it will be C and H4. Okay, so H is 4. When C2H6, it will be C2, 2C, and H will be 6. 2, 3, 4, 5, and 6. Okay, now this is C3H8, so C will be 3 and H will be 8, because each carbon atom will be combined with one hydrogen atom. It's very easy. I hope you understand this. Now when C4H10, so C will be 4 and H will be 10. How you know? So I'm not writing H here. You will be writing H by yourself. When C is 5, H is 12. 1, 2, 3, 4, 5 and H is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. When C is 6, H is 14. 3, 4, 5, 6. 1, 2, 3, 4, 5 and 6. H is 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13 and 14. And it will be continue like this. So, okay. So, what are the alkanes? Alkanes are the hydrocarbons in which the carbon bond atoms are connected only by a single bond. Okay. So, it is very easy. So today we'll be only doing this alkanes, and in our next lecture we'll be doing about saturated hydrocarbons, which will be alkenes and alkynes. So this is again very easy, but if we'll do all in once, it will be mess for you. So we'll be doing it step by step, one by one. So for today I think only this is enough. So please go through this and just let me know that whether you understood or not. So by the end of this, you will be doing some question and answers. I think it's easy, and if you have any problem, you can ask me so that I can help you out. Okay, so till then, please do your question and answers, and I want you to write all these things in your notebooks. Okay, so please go through the video properly and do all the question and answers which I'll be giving you. Okay, till then, take care and do rest. Thank you.